This video is all about word problems. So this slide has just some tips for word problems. Um, Not all word problems are the same. Every single one is going to be a little different. So there's not just a cookie cutter way of saying this is how you solve them. But these are some tips that will hopefully help you. Read the problem carefully. You want to make sure you can identify what's being asked. It's helpful to highlight, underline key things. Define your variables, so make sure that you know what you're looking for. Try to write out what you're looking for. That's super helpful sometimes. Use the words that we did when we did translating words into equations. So use those tools that you learned about that to write your equations. Use the rules for solving equations when you're working them. Always simplify. And then check your answers. Plug your solutions back into the problem. Make sure they make sense. And please include units. Okay. All right, so let's look at some examples. So these, really the only thing to do is just look at example after example after example. So I'm going to do a few for you. So this one says the width of a rectangle is 6 kilometers less than twice its length. If its area is 80 square kilometers, find the dimensions of the rectangle. So it says the width of a rectangle is 6 kilometers less than twice its length. Okay, so let's write that out. The width, W is going to be my width. We'll let L be my length. And it says that the width is 6 kilometers less than twice its length. So remember, less than means we had to switch that order. So 2 twice the length, 6 less. Okay, so I've got one equation. If its area is 80 square kilometers, okay, so we'll say area is 80 kilometers squared. We're trying to find the dimensions, right? That means we need to find the length and the width. All right, so how does knowing the area help me? Well, what is the area? Area is length times width. So let's make a picture. I like pictures. Pictures help me kind of get my mind straight and figure out what I want to do. So I've got length and I've got width. I don't know anything about the length, but I do know that the width is 2L minus 6. So if I know that, and I've got this, and I've got this, both of those are in terms of length. I could work with that. And then I know that the area is 80 square kilometers. Hey, I could find that. So area equals length times width. Area is 80. Length times width, but the width is 2L minus 6. Well, now I've narrowed it down to one variable. So we could solve this. So 80 equals, I can distribute that, 2L squared minus 6L. Now it's a quadratic, and we learned how to solve quadratics. We just need to set this equal to 0. So I need to subtract that 80 over. So 0 equals 2L squared minus 6L minus 80. So I'm going to solve this just like any other quadratic. I'm going to get a GCF. So I can take out a 2. L squared minus 3L minus 40. Now I need to factor. So I need numbers that are going to multiply to negative 40 and add to negative 3. So let's see, those numbers are going to be 5 and negative 8. So that means, see, I'm going to scoot up here. 0 equals, I've got 2. This is going to be L plus 5 and L minus 8. I'm going to use the zero factor property that says each one of these things, right? So I've got 1, 2, 3. One of them has to be 0. Well, does it make any sense for me to say 2 equals 0? No. So that's just kind of gone. L plus 5 equals 0. Well, that tells me that L equals negative 5. Well, can I have a negative 5 length? No. So that one's gone. Let's hope this last one gives me something. L minus 8 equals 0. So that tells that L equals 8. Finally, something I can work with. So L equals 8. That means that the length is 8. And I need a unit. Since the area was kilometers and it said 6 kilometers, that means that the length is 8 kilometers. But I need to know the dimensions, which means I also need to find the width. Well, in the problem, it told me the width was 6 kilometers, less than twice the length. And I also wrote that equation. So if I know that the length is 8, I can solve for my width. The width is 2 times 8 minus 6. So the width is going to be 10. So that means my width is 10 kilometers. All right, let's look at another one. It says an object is thrown upward from the top of a 160-foot building with an initial velocity of 48 feet per second. The height h of the object after t seconds is given by the quadratic equation h equals negative 16t squared plus 48t plus 160. When will the object hit the ground? All right, so let's wrap our brain around what this is saying. So it says an object is thrown upward from the top of a 160-foot building. So what this is saying is that we're at the top of this building, okay? We're going to throw an object up, and then it's going to come down. So we've got a quadratic equation, and it says that the height h of the object after t seconds is given by this equation. All right, so we definitely need the equation. When will the object hit the ground? Well, if this is telling us about height, okay, we're starting at 160. We're going to throw it up, and then it's going to go down. Well, if I want to know when is it going to hit the ground, that height should be at 0, which means that h should be 0. So I'm just going to take this equation and say, okay, well, 0 equals negative 16t squared plus 48t plus 160. And now I need to solve. So it's already equal to 0. So we're going to factor. I'm going to look for a GCF. GCF in this is negative 16. So I can take out negative 16. That's going to leave me with t squared. I'm going to divide by negative 16, so that's going to leave me with a negative 3t minus 10. Now I'm going to factor that trinomial. So I need numbers that are going to multiply to negative 10 and add to negative 3. So those numbers are going to be negative 5 and positive 2. So I'm going to bring down 0 equals negative 16. I'm going to rewrite this as t minus 5 and t plus 2. Again, just like before, we've got 1, 2, 3 pieces. Zero product tells us that either this, or this has to equal 0. Now, negative 16 equals 0 makes no sense. This one's going to give me t equals 5. And this is going to give me t equals negative 2. Well, time can't be negative. So that means that t equals 5 has to be the one I want. Again, we need some units here. Everything up here is seconds, t seconds. So that means that it's going to be 5 seconds. Let's do another one. It says if the sides of a square are increased by 2 meters, the area becomes 100 square meters. Find the length of a side of the original square. So what this is saying is we've got a square. It says the sides are increased by 2. So the side is going to become 2 larger, so s plus 2. The area becomes 100 square meters. We want to find the length of the original square. So that means that it's s. S is going to be the length of the original side. So area of a square is equal to the side squared. So in this case, it says 100. The side is s plus 2 squared. So when you square that, that just means that it's side times side. So s plus 2 times s plus 2. So I'm going to multiply that out. So that's s squared plus 2s plus 2s plus 4. Combine like terms. So s squared plus 4s plus 4. Now I need to set that equal to 0. So I'm going to subtract 100. So s squared plus 4s minus 96. Now that we've got it equal to 0, we can factor. So I'm going to look for numbers that multiply to negative 96, but add to positive 4. Those numbers are going to be negative 8 and 12. So I'm going to move up here. So that's going to become 0 equals s minus 8 and s plus 12. So this time I have 2. So s minus 8 equals 0 and s plus 12 equals 0. So that means that s equals 8 or s equals negative 12. And remember, s was the length of a side. That makes no sense. So that means that my side is 8 meters. One last example. A window washer accidentally drops a bucket from the top of a 64-foot building. The height h of the bucket after t seconds is given by h equals negative 16t squared plus 64. When will the bucket hit the ground? So he's on the top of a 64-foot building. He drops the bucket. It's going to go whoop and hit the ground. So remember, on the ground, our height is 0. So I'm going to take this function, and we're going to set it equal to 0. Okay, I need to factor this. I don't have to make a table for this one. I'm going to just factor out a GCF first. So my GCF, negative 16. I get t squared minus 4. We're not making a table because we don't have 3 terms. We only have 2. And in these 2 terms, they're both perfect squares, which means this is a difference of squares. T squared, that means that A is T. 4 means that B is 2. So this is going to become T plus 2 and T minus 2. Now that it's factored, I can start solving. Remember, that makes no sense. That I can solve. So this one gives me t equals negative 2. Remember, t is seconds. Can't have negative 2 seconds. This one gives me t equals 2. That's what I'm going with. So 2 seconds.